these are just the worked examples in your textbook, but I'm just going to make one video. It's probably going to be really long, but going over them. So example 3 is how we list sets. So we want to consider that the given events A and B that involve numbers taken from the first 10 positive integers. So we're only looking at positive numbers, and remember that integers is another word for a whole number. So set A has 1, 2, 3, 4, 5, and 6, and set B has 1, 3, 7, and 8. So the first part of this question is we want to represent the two events, A and B, in a Venn diagram, showing the number of elements belonging to each region. So what we're going to do is we're going to just draw our box, and we're going to draw our two circles in our Venn diagram and label A and B. That's a really good starting place. So in an exam situation, if you were able to do this, this shows that you, one, know what a Venn diagram is, and you're somewhat on the right track. So the next thing we want to do is show the number of elements belonging to each region. So I always find it's easiest starting with this center bit here. So when I look at set A and set B, I can see I've got 1, 3, and that's it. So there's two shared elements between them. So I'm going to put my 2 in the middle here. The next thing I'm going to look at is I'm going to go to set A. And we can see there's 1, 2, 3, 4, 5, 6. 6 total elements in A. But the trick here is that we've already got 2 elements in A here, so there's going to be only 4 left. So if we look at all of our A circle, we have a total of 6 elements, but just 2 of them are shared with B. Set B has 1, 3, 7, and 8. So there's 4 elements, but remembering that there's 2 shared in here, so then there's 2 left over. So in total, B has 4 elements. Now, this is where we've got to look at the question. It says we're looking at the first 10 positive integers. We've got 6 in set A, and then not including any overlaps, we've got another 2 in set B. So that's a total of 8 elements. So there's 2 left over, and that's why we write this 2 down here. It's the 2 elements that don't belong to any set. I find it's a lot easier answering these questions when you have a Venn diagram. So if you can go from the sets to a Venn diagram, it's really helpful. The next thing we want to do is list the following sets. So we have A and B, and A or B. So A and B, remember, is just our center bit. So it's going to be 1 and 3, because there are only 2 shared elements. When we look at A or B, we can be A, we can be B, or we can be a combination of both. So we're going to just list all our numbers that belong to those sets. So it's 1, 2, 3, 4, 5, 6, 7, and 8. Remembering, if we've got, say, 1 and 3 in both sets, we only write it once. Now that we've got that, we want to look at question C. So if a number from the first 10 positive integers is randomly selected, find the probability that the following event occurs. So we want event A, we want the event of A and B, and the event of A or B. So remembering, we need to write PR and then what we're finding. So the probability of A, there's a total of 6 elements that belong to A out of 10 possible elements. So it'll be 6 over 10, or simplifies to 3 over 5. A and B, remembering that's our center bit here, there's a total of 2 elements out of a possible 10, which simplifies to 1 over 5. And finally, there's A or B. So in total, there's 8 possible options that fall in A or B. So 8 over 10, or simplifies to 4 over 5. Our last part are other events A and B mutually exclusive, why or why not. So the sets A and B are not mutually exclusive, since A and B is not. So for them to be mutually exclusive, it means we would have no crossover in this center bit. So because there are elements that belong into both sets, they are not mutually exclusive. Alright, example 4. So we're getting a bit more into a word problem now. So from a class of 30 students, 12 enjoy cricket, 14 enjoy netball, and 6 enjoy both cricket and netball. We want to illustrate this in a Venn diagram, state the number of students who enjoy netball only, or neither cricket nor netball, and find the probability that a student chosen randomly from this class will enjoy netball, netball only, or both cricket and netball. So we know there's 30 students in total. If we add all of these up, we have got 12 and 14 is 26. 26 plus 6 is going to get us to 32. So that's more than the total number of students in the class. So what we need to do is think about it in terms of, well, there's 6 that enjoy both, so the 6 are included in this 14 and this 12. So again, I'm going to draw my box, draw my circles. I'm using C for cricket and N for netball. I always start with our middle, so R, A and B, or in this case, C and N. So 6 enjoy both, so I'm going to put 6 in the middle. What I then need to do is when I'm looking at cricket, there's 12 in total, but we already have 6 in the middle, so there's only going to be 6 here. So if we look at the total in the cricket circle, there's 6 and 6, which is 12. We do the same thing with netball. There is a total of 14, but we already have 6 in the middle. So 14 minus 6 leaves us with 8, so the total in netball is R14. So a quick way to then do this is you can do your 6 and your 8 if you like. It's probably the easiest because remembering this 12 and this 14 both contain that 6. So 6 plus 6 is 12, 12 plus 8 is 20. We know there's 30 students in the class, so there's 10 who like neither. So we now want to state the number of students who enjoy netball only. So we write number, so remember that N's for number, and only equals 8, because these 8 are the ones that enjoy only netball. Neither cricket nor netball, they're going to be R10 sitting on the outside that aren't included in the circles of our Venn diagram. The next part is find the probability that a student chosen at random from the class will enjoy netball. So we write probability of N, so netball. We know 14 in total like netball, so 14 over 30, which simplifies to 7 over 15. Netball only, there's 8, so it's 8 over 30, which simplifies to 4 over 15. And finally, both cricket and netball, we can write that as the probability of C and N. That's our center part. There's a total of 6 over 30, which simplifies to 1 over 5. And that's it for that example. I think we have one more. I might do this one in a separate video just because it's going to take a while.